In my last video, I showed how to parse a log using regular expressions, but to do that, I actually had to create a whole bunch of logs. Well, when I first started, it was a little slow, I will admit, but I did make it go a little faster. Now let's make some of this text a little bigger here, and I want to show some of those things that I did that really helped it speed up a bit. I will say that the first thing I want to show you didn't help this code run faster, but it did speed up me looking at it, which is this right here. So you can cast a string to an int if it's a bunch of numbers. And when I was typing 10 or I was typing 100 or 1,000, that was pretty easy. But I started getting into the bigger numbers and I started wondering, what is that number right there? So I would go and look at it and say, all right, there's 3 and there's 3. So that's 10 million right there. Okay. Well, I didn't really want to do that every time. After a few times, I just said, hey, let's go back to the old string. You write it as you would if you were typing it out, or handwriting it out, 80, comma, 000, 1,000, right? Put it in quotes, cast it to int, which is integer. And that worked for me. Then, instead of writing the get date out with the year and the month and all that, this is another easy way. It doesn't really make the code run a whole lot faster. Well, it might. I could time that at some point, but it is faster for me to just look at it and say, all right, which one is it? And easier for me to come in here and look and see exactly what I want to do. If I want to change the month of the day, I read that format pretty quickly. The next was I was creating a whole bunch of doors and I was giving them IDs with A1, A2, Z3. I needed a whole bunch of doors for this door service that I was creating and generating a ton of log entries for. So what I did is, if you run this right here, you'll see it is, there we go, just A to Z. It gives you those letters. They're not strings, right? Even though they got those quotes around them, they're just a single character. So what it's doing is it's saying, hey, from the letter A to the letter Z, in this case, all caps. If I did A in lowercase, right? If I could type right, A, comma, or dot, Z, it will give me those as well, but they're the lowercase. Now, what you can also do is A, dot, Z, and then join them, like you see in my hint there, and that's just going to make it easier to read. It's going to join them all together, but now you have a string. They're no longer just the characters. You can't take that and give it an ASCII number. This next one was a really big boost in speed for me. This is random, right? System.random. And then you call that new constructor method on it, and it's going to give you a random object, and you can use that to generate random numbers. So in this case, random.next. There we go. And it's going to give you some random number. It's going to be an integer. So these are big numbers, right? Now, you might have also seen you could also do double, and that'll give you a random number, but it is somewhere between 0 and 1. So it's a decimal, it's a double, right? Some random number. Those help me a lot. And the reason that helps a lot, it comes into handy in a few places, but let's take a look at what I've got here. So I'm going to go ahead and run all of this up until that point. That's going to generate those doors for me. And then let's take a look at what the speed difference might be for these. So I now have a doors array. It has a 1. Remember, I was using the letters and the numbers. And then I've got a whole bunch of them. How many? Doors.count. I have 1,560. You can also do that with doors measure object. And that'll give you the same thing. And the count is 1,560. And that's going to measure your array. Now, I was doing this in a log entry creation and generating these, which is fine. And initially, I just create these, and I'm going one at a time. So for each letter and for each number, and that's fine. But then I was getting random doors in the doors array, but I was doing it many, many times. So that's where we're going to see the time difference here. Let's do this. I'll break it down first. So 1 to 10,000. And for each of those, that is a for each object. You can also type for each object, right? And then I'm going to say doors get random. Now, I don't actually want to see those doors right now. I want to show you that doing that 10,000 times can take a little while. So I'm going to give it measure command, and it's going to run that 10,000 times, just getting a random door, and it's going to time that for me. Now, how long does it take? Now, I was doing this millions of times, right? That took 10.2 seconds. That took a little bit of time. Now, it's not a tremendous amount of time. I get it. It's not. But the difference between that and random is very big. So how do we do it? With using the random. So we're going to go to doors, and instead of giving it like 0 or 100 or 103, I am going to say, give me random.next, and 0 is the starting point, and then doors.count is the end point. Right now, doing that 10,000 times took less than a half second. So if I'm doing this millions of times and it's going to run 10 seconds or a half second per time, this is a tremendous amount of savings in time. That helped me a lot. So let's look for what the next one was that saved me some time. Now this one I'm going to explain, but I'm not going to do a big example of it. I think you'll get it just from the idea of how I explain it. Okay, so this is for each object, right? So I do 1 to the number of days to log. I could do 5 days, 100 days, or I could just do 30 days, 1 month, right? But for each of those, I'm going to then generate a whole bunch of log entries. And if I were to do those 1 day at a time, I have to wait for the first day to finish and then start the next one to generate those logs. It does take a little while. In fact, it took an hour and a half before I did all of these optimizations to my code. Then I decided, hey, I'm going to do those in parallel, which means for each object, parallel is a handy way to say, hey, computer, I want you to use a whole bunch of those CPU cores that you've got. So not many people are running single core computers these days, at least not on something where they're going to be running big scripts like this or doing development on it. That is a great way to say, let's use as many as we can and run them all at the same time. Well, in this case, I actually defined it with a throttle limit. And I said, hey, let's do it 10 at a time. So it's going to go through these and run 10 days of log entries at a time, which was great. I had enough cores to throw at it. And even if you don't have a ton of cores, it will still help to do at least 2 at a time or 3 at a time. So that running for each object in parallel definitely saved me a bunch of time. If we go down here, I create a log folder path, and I define the log folder path, and then I create this string to say, hey, that's the log file name that I want to use. So in that folder, I give it the year, month, and day, and .log after door security, because that's just what I was calling the logs. And then I use a write stream. Okay, now it's really a file stream, and I'm writing to that. I call it a write stream. What I'm doing is I'm creating a new item using the new item commandlet. But you can use get item if you've already got a log there and you just want to start writing to it. But then it has a method on it. So I enclose that in parentheses, and I call the append text method. That opens that file up for me to start writing to. I can close it later. That's the time savings. That overhead of opening and closing that file takes a while, especially if you're doing it after every log entry, which you probably shouldn't do in the first place. But even if you're doing it every day of log that you're writing, or every 5 minutes you write to it, this keeps that file open instead of open and close and open and close. If you've ever used something like Excel, when you double click that, it doesn't open instantaneously. It takes a second or a few seconds. And if you got a slow enough computer, it might take like 10 to 15 seconds. But the point is, now I only have to do that one time instead of a whole bunch of times. So I just keep it open. And then in the end of all this, I actually do flush what's in memory, write it to the file, and close it. Now, what I'm doing in here is inside that loop for each day, so right here you have if sample log modulus 5,000, so percent is modulus, 5,000 is equal to 0. Sample log is what I use, just how many times I'm writing or creating a log entry. Someone opens a door, that's a sample log. Okay, I could have called it sample log entry. But for each one of these, if I accumulate 5,000, I go ahead and flush that out to that file. And I say, hey, I don't want that in memory anymore. Go ahead and put that in the data file. And then, of course, after I do all of the logs for that entire day, I close the file. And that was really good time savings. Let's go back up a moment. This one, I actually had to use AI for. I ran through this with my son. He loves math. And we did some experiments and saw that this is pretty cool. And it does create the effect that I wanted. For the most part, I could probably find a way to tune it and make it a little better, but this worked out pretty well for me. So in this case, I wanted a random time delta between the events, right, on the hour of the day. So what I mean is, if they come in, this was for a door service. So if that person is coming in to work and it's before 7 a.m., well, then I run the code in this line. If they come in before 8, I run it this line. And you see these numbers here, they do change, right? So all down here, you can see every hour that I have defined here, they have a different number over here. So let's break out what this is doing. Now this, I got to tell you, was really cool. And what I wanted to do is have an effect where it generally weighted the number that resulted in it towards 0. So more often than not, I'd get 0 or 1 seconds. And what I was thinking is, I have a bunch of people going into work. Most of them come in around some similar times. So I wanted them to appear in the logs as if they are coming in more frequently around those times. And that is with this right here. This starts right there with random.nextDouble. So I was showing you earlier, you can get a double, which is a number between 0 and 1. Well, that's my raw number, and that's what I'm going to use down here. And I'm going to floor this number, which just means round it down. And then I'm going to multiply whatever the max number is that I want that to be. And actually, this becomes exclusive, not inclusive max. So it's not going to ever fully reach 5. It could be 4.999, but it's not going to be 5. And then I'm going to multiply that by that raw number, that double that I got up there. And you could just multiply it by that double. And then that will give you, that a number less than 5, greater than 1. Or you could square that raw number, and that will make it weight a little more towards 0. So 0 or 1 or 2 is more common than 3 or 4. Or you can cube that number, raw times raw times raw, and that'll weight it even more towards 0. And in this case, I did to the 4th power, and that was good enough for me. That did pretty much what I wanted. So more often than not, I get a 0. Now let's see how this works. Okay, I'm gonna do an example down here. I'm gonna say 1 to 10,000, just like I did earlier, for each object. And then I'm going to say that raw equals random.next. And then I'm going to run this next line, but I don't need to save it as a variable. I can just output that. So let's copy this, paste it down there, close that for each loop. And then what I'm going to do is I'm going to do a group object on that so we can see that how many of these come up as a 0 or a 1 or a 2. So in this case, we've got 0, 6,747 times. We got 1, 1,212 times. 2, 852. So you see, we get fewer and fewer the bigger the number goes. We don't ever get 5 out of those 10,000 times, but it does have that curve going down from 0 to 4. More commonly is going to give us that 0 number, and then a little less common 1, a little less common 2, a little less common 3, and 4. Now, as you can see, it really does weight towards 0 quite a bit. Those are some tips, some things that I used to make things go faster for me. One of them was just reading it. Another is kind of reading it too. I don't know if getData is faster. Using the array of chars to create my doors, that helped. I don't have to write out that array anymore. Using system.random is also a big help. And I will tell you, you don't actually have to write system.random. You can actually just put random in the square braces there and it will still work. So that one was a tremendous time savings. The parallel, which is right here, that was also a tremendous time savings. Definitely helped out. And the write stream. So when I'm coming down to that bottom and I don't have to open and close that file every time, right? That was another time savings. I don't actually know if I should just save it all in memory until the end of it, but there's, I was doing about 90,000 badge swipes a day, or events, log entries. They could be no badge swipe, right? It could be a forced entry of some sort, but log entries, like 90,000 per log. I'm not sure what that would do to the memory. I actually didn't try that, well, I didn't pay attention to it before I wrote the write stream. Yeah, there you go. Those are some time savings. They helped me. They might help you too. Good luck.